So when you see an irregular shape that you're trying to calculate the area, perimeter sometimes is a whole different ball game. Perimeter can be a little bit funky. But for area, what you want to think about is, can you break it up into pieces that you know? So actually, for many of these, there's more than one answer. When you look at this shape, consider the fact that technically you are stacking together two rectangles. So you can break it apart here, as they've done in the picture, but it's not incorrect to break it apart here and then use those two rectangles. So there are many ways to do these. Many math problems have many ways to accomplish them. So know that sometimes you're going to, go one way and your friend go another way and get the same answer. That's okay. So let's do it the way that they did. So if you look, the thing that you want to consider is, what measurements have they given us and how can we tell what those measurements are? So let's focus on this shape for a minute. If we break it down right there, and I'm sorry that's so not straight, but if we break it down right there, this is probably not going to be much better, but if we break it down right there, you can clearly see that this one is 3, but don't use the 7. This one is 3 by 4. Okay, so that piece right there is 3 by 4. Now, if you analyze this piece, you got to use the 5 and the 3, and this piece is 5 by 3. So just be careful, because some of the measurements they give you might be the total side. Okay, so like I've seen some people do problems like this where they calculate the whole thing and then they take this piece away and they use subtraction instead of addition. So like I said, there's many, many ways to do this. If you use what they have said, they did the 3 by 4, that's area 1. Then they did the 5 by 3, that's area 2. And the total area, then, you're just going to add those two things together. So it's just a matter of how do you break it up in a way that is helpful. Okay? Now I'm going to show you on the bottom the way that I think you should break it up. Not really the way you should, the way that occurs to my brain. So, who knows what that means. But when you look at this first example here, commonly what I'll see is that you'll break it right here. Now be careful when you're using these measurements. Can somebody tell me, if you break it this way, what are the dimensions we're going to use for the top rectangle? Can somebody tell me what they use for the top? Tommy, what did you use?
10 and 5.
So you use 10 and 5. Okay, now let's focus for a minute on the bottom. What measurements do we have to use on that little tiny rectangle in the bottom right corner? Yes, 3 and 4. So remember, area for a rectangle is just length times width, so it's not a huge, crazy calculation. Just show me what your two area measurements are, even if you're right inside the rectangle like I have. This top one would be 50, and what units should we use for that one? Square centimeters, or, just you can put the cm with the little 2 on it. And then our 3 times 4, that would be 12 square centimeters. But remember, they're looking at the total area of the room or the figure or whatever it is. So now I just want you to show me that the total area is 50 plus 12, or 62 square centimeters. And make sure you're using that that units on there, okay? So your first one there, you're going to get 62. Not an issue. It should have been pretty clear. Now, if you broke it up here, and you use that rectangle and that rectangle, as long as you got 62, you did it right. You're good to go. So note, again, these have many different answers. Let's take a look at number 2 here. Now I'm going to show you an alternate way to do this one. You could break it here into 3 pieces. So you'd have that rectangle and those two. So that's totally legit. You can do it. You can break this here into 3 pieces. So that would be your 3 pieces and you'd have 3 measurements. That's legitimate. But what I'm going to do is I'm going to show you a different alternate measurement. I'm going to think about if I did the whole thing and then I chopped away or subtracted that area. So then we actually only have 2 measurements to do instead of 3. Now, if you did it with 3, go for it. You can check your work as to what I do. You don't have to change it. Again, I don't care, okay? But let's figure if we had this whole thing, what is the measurement if it was a normal rectangle completely filled in like this? What's the length and width of that particular thing? 6 times 12, right? Okay. So that 72 square millimeters, those are millimeters if you didn't know that. Meter is an M, and with a prefix in front of another M is millimeter. That's 72 square centimeters. If that was a rectangle that wasn't missing a section, and then what is the dimension of the missing section? So this is 3, this is 4. It's pretty clear that this is 3 by 4. 3 times 4 is 12. So you can then just take off 12 square millimeters. So the answer would be 60 of the pieces that are there. So that's one way to do it. That's totally okay. You can do the big thing minus the little thing, and you get what's left. So that's a tactic I've seen used quite often. But let's say you just decided to cut it into 3 pieces. Okay? Let's just show you that it's going to get an answer of 60. Okay? So let's just kind of clear up, hey, it is going to work. It is going to give us 60. Okay, so the first piece. If you really look at how that is, this rectangle here is 6 by 4 or 24. Okay. This rectangle here is the hard one. Now, let's think for a minute. We have it marked 4 here. We don't have the markings here. Wait. We don't have the markings, do we? Oh, yeah, we do. Okay, we have enough information. So this is the total of 6. Up to here is 3. So up to this line is 3. What would this line have to be to make a total of 6? So if this whole thing is 6, and we know up to here is 3, what would this one have to be? It also have to be 3. Remember, it has to total to the measurement you see on the screen. So this is going to be 4 times 3, or 12. And then if you compare this rectangle to this rectangle, don't always assume it's to scale and perfect and lovely, but it is. It's 6 by 4 or 24. And 24 plus 24 is 48, plus 12 is 60. So you still get 60 no matter how you do it, whether you take the big thing minus that piece, whether you break it into these 3 pieces, whether you break it into those 3 pieces. There's no one right answer. I mean, there's a right answer of 60. There's no one right method to use. So I'm not ever going to be particular if you broke it up differently than someone else, as long as you get the 60. Any questions on number 2? Okay, let's do 3 and 4. For 3, when I just visualize this weird tower on the top, I just think, why not break it there? It's probably the most efficient way to do that one. Now, the bottom's pretty clearly marked 5 by 9. So 5 times 9 is 45, and our units are meters, so it's square meters. This one, sometimes they're clearly marked, but like the last one, sometimes you have to do some calculations. This one is marked as 1 by 4. 1 times 4 is 4 square meters. So then just total it up. 45 plus 4 is 49 square meters. Okay. And again, there's so many ways to do these problems. So then I want to give you a minute here. Wait, first, do we have any questions about 1, 2, or 3 before I move on to the last one? Any questions about 1, 2, or 3? Okay, so let's take a look at 4 now. Now be careful with 4. This measurement here, or this height, is 5. This one is 6. But do it however you want, whether you want to break it here into 3 things, whether you want to break it here into 3 things. This is not a great one to just take out one chunk because the things are not level. But go ahead and give that a shot, and then we'll check our work together before we turn this in, okay? So I'm going to break it down like you see on the board. It doesn't, you might have done it different. So keep yours, and then we can check it with mine in a second. Is there anyone that broke it down like I did that would share with the class? Okay, can you tell us what you got, Xavier?
So I did 5 times 4 for the first box.
Perfect.
Second box, I did 2 times 3.
Okay, let me just do some math here. 4.
The top, it's 2 centimeters, cutting that 5.
Perfect, perfect. Okay, so you did 2 by 3. Okay, perfect.
And then 3 times 6.
Okay, let me write that in, and then we'll discuss, 'cause that's perfect. Okay, so what he did was so nice. You did 4 times 5 for the 20. This one was a little, you had to, kind of do some thinking here. This one lines up here, and so we know that's 2. We only got to 2. This one, it would have to be 3. So they marked the 2 for us, so 3 by 2. This one was marked 3 by 6. And then you just totaled it up. 20 plus 6 plus 18. Can you tell us what total you got?
I got 44 centimeters squared.
Perfect. 44 centimeters squared, or square centimeters. 20 for the first box, 6 for the second, and 18 for the last. If you broke it up differently and still got 44, yay, you did it right. Okay. If you didn't get 44, check your measurements. Did you actually physically break it down correctly? And do that where you had to kind of compare it. What's missing if that one is 5? And then we've gone 2. 5 minus 2 is where you get that 3 right there. Okay. So that being said, this should be done. Could you, at this time, go into Google Classroom and take a picture where it says, I think 11A number 4. Okay. So if you could take a picture of that, turn that in for me, and then you'll have one to do yourself in class today.